then sent up through the specimen and the direct transmitted light, thus enabling the observer to view the organism stained in its true chemical color and revealing its own individual structure in a field which is brilliant with light. The rays of light refracted by the specimen enter the objective and are then carried up the tube in parallel rays through 21 light bins to the ocular, a tolerance of less than 1 wavelength of visible light only being permitted in the core beam. The rays start their rise parallel to each other, but just as they are about to cross, an especially designed quartz prism is inserted which serves to pull them out parallel again, another prism being inserted each time the rays are about ready to cross. Thus, the greatest distance that the image in the universal is projected through any one media, either quartz or air, is 30 millimeters, instead of the 160, 180, or 190 millimeters, as in the empty or air-filled tube of an ordinary microscope.
Recently, Zeiss and another company have developed microscopes based on Rife's technology that are capable of viewing living microorganisms. One such instrument is now being used in the United States for research. As Rife continued to toil in his lab, word of his accomplishments began to filter out to the community. Rife was interviewed by the local newspaper, and an article appeared as a front-page feature in the science section of the San Diego Union on November 3, 1929. The headline read, "Local Man Bears Wonders of Germ Life." The reporter described photos of several microorganisms Rife had isolated and filmed. This article touched off interest in other regions of the country, and Rife was featured in many other prominent newspapers and magazines. Eventually, as the news spread, there began first a trickle, then a rush of bacteriologists, doctors, and scientists from many related disciplines, beating a path to San Diego to see the new microscope and discuss Rife's findings. Shortly after the article on Rife and his microscope appeared in the San Diego Union, a professor of research bacteriology at Northwestern University Medical School in Chicago came across the story. That man, the eminent scientist Dr. Arthur Isaac Kendall, developer of the K-medium, called his good friend and colleague in Los Angeles, Dr. Milbank Johnson. Kendall wanted to know if such a microscope, said to be 8 times more powerful than that used by physicists of the day, did indeed exist. Johnson contacted Rife, and soon Kendall made the journey to California, joining Johnson, Rife, and others at the Pasadena Hospital to verify the fantastic stories that they had been hearing about this young San Diego man and his microscope. Kendall was a leader in the bacteriology field, and more recently had advanced a controversial theory which held that viruses could morph into different forms under certain conditions. This theory might be likened to the morphic change that occurs in the life cycle of a butterfly. It begins with an egg, which hatches into a worm, then into a cocoon, and then to butterfly. One essential organism, but differing forms based on changing food sources and environment. This pleomorphic concept was first advanced in 1898 by the Louis Pasteur Institute and Antoine Béchamp in France. Following that theory, Kendall postulated that the typhoid virus, for instance, under certain conditions, could become much smaller in order to survive. Scientists at the time called this smaller form a filterable mode. This so-called filtration made the virus undetectable under standard microscopes, compromised its control, and it made Kendall's theory of polymorphism impossible to prove, until he saw it happen under Rife's microscope. Kendall had invented a protein culture medium called K-medium, which enabled filterable portions of a bacterium to be isolated and continue reproducing without the need of living tissue for reproduction. A typhoid germ, typhoid bacillus, ordinarily a fairly large germ, easily visible, was put in the K-medium. triple filtered through the finest filter available, and the results examined under Rife's microscope. The gentlemen gathered there were able to observe for the first time 3 live stages of the development of the typhoid bacillus. In its filterable form, tiny, distinct bodies stained in a turquoise blue light were visible. For the first time, Kendall could see the proof of what he had demonstrated by other means. This experiment showed that viruses and bacteria were capable of mutating or changing their form. This fact generated much controversy then, as it still does to this day. Kendall's pleomorphism theory and the usefulness of his K-medium had been verified. And the viruses could be light-stained and then classified according to their own colors under Rife's unique microscope. The tests were repeated 18 times over several days to verify correctness. Dr. Milbank Johnson organized a press conference and banquet to commemorate these great events, calling it the end of all disease. Johnson, a well-known and influential MD, was medical director of the Pacific Mutual Life Insurance Company. He is seen here in the back of the room by the window with Dr. Rife on the right and Dr. Kendall on the left. Others pictured here, Dr. Alvin G. Ford and Joseph Hitchker, had gone with Dr. Johnson to meet Rife at his lab in San Diego. After this great collaboration in Pasadena, Johnson introduced Rife to other doctors, promoting and publicizing Rife's work. He would become Rife's most powerful advocate. From that watershed event, Rife and his microscope were to become widely known. It was Rife's meeting and collaboration with Kendall which would help Rife make his greatest discovery, the cause and the cure for cancer. In June of 1932, at the invitation of Kendall, Rife traveled to Chicago to join him and E.C. Rosenau of the Mayo Clinic. The opportunity to work with Rosenau was a real coup for Rife. Rosenau was a renowned bacteriologist in his own right, and the three of them spent part of that summer re-verifying Rife's previous work with Kendall. Interestingly, Rosenau had heard of Rife through a patient of his. That patient was Henry H. Timken, Rife's primary financier. When he returned to San Diego, Rife continued with his magnificent obsession, finding a cure for cancer. Rife had always suspected that cancer was a virus, first beginning as some form of microorganism that would, under the right conditions, replicate itself within animal or human cells. Years of microscopic examination of more than 20,000 specimens had yielded no results. But his collaboration with Arthur Kendall had brought the K-medium to his lab, and that was the link Rife needed to find the cancer virus. Rife would later recount to a San Diego Evening Tribune reporter how the final events leading to the discovery of the cancer virus came to pass, primarily by mistake. The reporter's article summarizes what Dr. Rife said.
But neither the medium nor the microscope was sufficient alone to reveal the filter-passing organism Rife found in cancers, he recounted. It was an added treatment which he found virtually by chance that finally made this possible, he related. He happened to rest a test tube of cancer culture within the circle of a tubular glass ring filled with argon gas, activated by an electrical current which he had been using and experimenting with electronic bombardment of organisms of disease, he recounted. It happened to rest there about 24 hours, and then he noticed that its appearance seemed to have changed. He studied and tested this phenomenon repeatedly, and finally one day, he discovered filter-passing red-purple granules in the cultures.
Rife suspected he had isolated the cancer virus, and he dubbed this organism Bacillus X, or BX. It was pleomorphic. The article goes on to state that Rife proceeded to uncover many other disease-causing organisms.
Among the filter-passing forms he reported isolated were those for cancer, although he frankly declares that he is not yet positive that this is the direct cause of the dread disease. B. coli, the seemingly harmless bacillus